Hello, and welcome to video 2 for this unit on rigid transformations and congruence. In this video, we're going to focus on properties of rigid transformations. The transformations we've learned about so far, translations, rotations, reflections, and sequences of these motions, are all examples of rigid transformations. A rigid transformation is a move that doesn't change measurements on a figure. Let's reason about properties of rigid transformations to find the measurements without measuring. Earlier, we learned that a figure and its image have corresponding points. With a rigid transformation, figures like polygons also have corresponding sides and corresponding angles. These corresponding parts have the same measurements. Here's a triangle ABC and the measurements for its 3 angles and 3 sides. Let's reflect triangle ABC over line AC and then translate right and up. We now have triangle EFD, which is the image of triangle ABC. We could also have named this triangle A', B', C', or OPQ. How you name points on the image is up to you. Since we used a sequence of rigid transformations, then we know that the corresponding sides have equal length and corresponding angles have equal measure. These facts let us figure out things without having to measure them. For example, since segment AB is 2 24/100 units, we know that corresponding segment EF is also 2 24/100 units in length. It is also true that since angle BCA is 45 degrees, corresponding angle FDE is 45 degrees. Here are the other corresponding measurements. When we construct figures using copies of a figure made with rigid transformations, we know that the measures of the images of the segments and angles will be equal to the measures of the original segments and angles. Let's consider corresponding parts when we rotate a figure. Here is a line segment CD with midpoint G and a point E not on the segment. When we apply a 180-degree rotation to a line segment, there are several possible outcomes. Keep in mind that since it is a 180-degree rotation, we can rotate clockwise or counterclockwise and get the same result. If the center of rotation is the midpoint of the segment maps to itself. Here, a 180-degree rotation of segment CD around point G results in an image that is segment DC. If the center of rotation is a point on the segment, the image of the segment overlaps with the segment and lies in the same line. Here, a 180-degree rotation of segment CD around point D results in the image AD. The image of the segment does not overlap with the segment if the center of rotation is not on the segment. Here, a 180-degree rotation of segment CD around point E results in the image BF. Rigid transformations have the following properties. A rigid transformation of a line is a line. Here, the line is rotated 180 degrees clockwise around point P. The image is a line parallel to the original line. A rigid transformation of 2 parallel lines results in 2 parallel lines that are the same distance apart as the original 2 lines. These parallel lines are rotated 90 degrees clockwise around point P. Sometimes a rigid transformation takes a line to itself. For example, a translation parallel to a line Here, the arrow shows the distance and direction of the translation of line M that will take M to itself and a point P on the line to a point P' on the line. A rotation by 180 degrees around any point on the line. Here, a 180-degree rotation of line M around point P will take M to itself. A reflection across any line perpendicular to the line. Here, a reflection of line M across the dashed line will take M to itself. These facts about corresponding parts and rigid transformations let us make an important conclusion. If two lines intersect at a point, which we'll call O, then a 180-degree rotation of the lines with center O shows that vertical angles have the same measure. Vertical angles are opposite angles that share the same vertex. Here's an example. Angle AOC measures 140 degrees. Rotating both lines by 180 degrees around the point of intersection O sends angle AOC to angle A'OC', proving that these vertical angles have the same measure of 140 degrees. The rotation also sends angle AOC' to angle A'OC. These vertical angles have the same measure of 40 degrees. Thank you for watching video 2 of 4 for this unit on rigid transformations and congruence.